So this is the code for the pre-trained model. So we learn the first part of this pre-trained model. For example, I give you the example how to call the pre-trained model. The calling the pre-trained model means you need to understand what are the model name. So in this case, I'm using Word. The one that you can use for free, it is only some of the earlier model. Earlier model means the model that has been developed long time ago, like 2017 or 2018. And it is difficult to get the free access for the new model. But I guess it is still relevant with the old model, like with the AMKIS. And you can call this model, and then you can make the text classification. For example, I want to know what will be this text. So in this case, this is just a very simple classification. We are going to classify whether it is level 1 or level 2. So level 1 means whether it is one of the texts that are relevant or not. So you can also use different kind of tasks. We call it this is tasks. The first task is the text classification. The other task is the sentiment pipeline. So we already know if it is classification, then maybe we have two levels. For example, in your assignment 1, it is the clickbait and not clickbait. So you can define what is level 1, what is level 0. For the sentiment, it's also the same. The basic sentiment is positive, negative, and neutral. So you can define also what is the label that we want to infer. The other kind of pipeline, we have the question answering pipeline. So we have the text classification, we have sentiment pipeline, we have the question and answer queuing. So when you do the question and answer pipeline, so you can just give the question and what is the context, and the result will show what will be the best answer to present for the question. The other kind of pipeline we can use for name entity recognition. So we know that the name entity recognition means we can understand this is person. John is his first name. New York. New York is a location. Google. Google is a location, or is this a company? And we can also look at the strategy. What is the aggregation strategy? The aggregation strategy means you can define if there are several words. For example, in this case, I have new and I have York. New is a word. So you can have like new food, new car, something like this one. So this word new may not represent some kind of place. So if new and York combine or aggregate, then it will represent a location. So we can use some aggregation strategy. And the other kind of pipeline in the pre-trained model that you can use is the text generation. So in the previous one, you can use from Word. So the text classification, you can use from Word. For the question and answer, you can use Word. And then for the sentiment, you use Word. For the text classification, you use Word. For text generation, usually you will use GPT. So GPT is the pre-trained model that is for free. So the GPT-3, GPT-4 is already for commercial. So you need to pay some money if you want to use that. So here you can just use the GPT-2, and then you can call the text generation pipeline. Means you want to generate a text. Text generation means, let's say I have some text like this one once upon a time, and then I want to give another text. So after upon a time, what will be the best sentences? So here, if you run this one once upon a time, the world was ruled by men. The rule of the fittest has never been in doubt or changed, and blah 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 blah. So the next text has been generated according to the model that they have. Okay, so that's the Word and GPT, and there are several pipelines that you can use. So if you can use it for your team project, that will be also good, because I know there are some things you use text classification. So it means you can use the text classification pipeline with Word. If you use sentiment analysis, then you can apply the sentiment pipeline. Let's say you have a question and you want to give answer to user. So you can use the question and answering pipeline. Maybe you want to define some places. There is one team who wants to recommend a place, but I'm not sure if this NPR pipeline can work for coding or not. But this one has been developed based on the English. So please check whether your work will be in Korean, or if you use the existing dataset, maybe it will work. Now, when we do with the text generation, or when we do with the other kind of tasks, so we can have some parameters. So let's see if I do this one. So you can define what are the models that you want to use. In this case, I will use GPT-2, and the model can have several parameters. For example, I want to use the head model. So when we use the head model, it means we want to focus more on some words. So the model name that we use is GPT-2, and I want to use the attention head model. And then I can also use the tokenizer that has been developed by a certain model. So in this case, the head model is focused for the GPT, and the tokenizer is also for the GPT. If you use the GPT base like this one, with the model GPT-2, then you can get a better result because you use in the same model. So there are many kind of pre-trained library, like the model, the tokenizer, or the embedding, or the other edit coding, and etc. So you can check those, according what model that you want to use. So in this case, I'm just using the head model and the tokenizer. So here, there is an option. If you are using the tokenizer, then there might be some issues, for example, how to handle padding. And let's say how to handle some new use cases. So we are going to use some pad token. So the token should be defined more. And the token, this is the E or S, it represents the end of sentence. So every end of sentence will be generated. So when you write a text, then you need to make sure that it will be ended. So the pipeline is the same with the previous one. So we call what is the pipeline. Let's say we are using the text generation, and we call the model, and also we call the tokenizer. So different tokenizer will give you different result. So the previous example that I showed here, you just use the model and then you put directly into the pipeline. But here we want to make more focus on the model. We want to use the head model and the tokenizer. Once we already define the head and the tokenizer, we can make the initial text. So in this case, I have once upon a time in the magical forest. So you can generate 100 additional text, and then just written one, and then do sample true, and then top K 50. So it means we want to find what will be the best representation of word by giving this input. So if I give the input about forest, if I give input about magical, if I give input about time, if I have input about once and upon, so there will be some additional words that are correlated with this word. So they will just look at what are the top 50 among those correlation words, and we can generate the next 100 words for the sentences. So it is better to use like the Google Colab. If you use your Jupyter Notebook, or if you use your Visual Studio Code, I'm afraid that those things will be saved into your computer. Or those kind of library like the config and the generation config, tokenizer config, and so on. So those data are represented in the JSON. So those data have to be saved into JSON, and because this is the pre-trained model, of course they need to access to this data. And you can see here the data is quite big for some data. Let's say this one is 500 mega. So if you use your computer to access this one, I'm afraid that you will need to save this into your local drive. If you save this into your local drive, you can have less capacity in your hardware. So using the Google Colab, I think it will be very good to save your space in your laptop. And you can see this one, the text generation result. Once upon a time in a magical forest, a man came up with some strange idea. He thought it would fun, play, and so on. So you can measure this one is about 100 like. So when we use the other class, is also the same. We can consider the tokenizer. So we can specify the tokenizer. In the previous one, we just apply the model, but we can consider what is the best tokenizer. So in this case, I just use the tokenizer that I defined previously. The tokenizer was from this GPT-2 tokenizer. So there will be another kind of tokenizer, so you can check what will be the best tokenizer according to your task. So let's say I'm using this function to generate the answer. So in order to generate the answer, first I would like to know what is the context and what is the question. And then after that, we can get the answer. So the input will be the tokenizer, and then we want to encode. So you know the encode means the encoder. And the input is to encode the input text, and we are going to use the tensors. So we already learned this one from the previous section. PT means PyTorch. So we can have also another tensor. For example, if you use the TensorFlow, so we can define as TF and so on. Once we have this encoding, then I want to generate the output. The output generation will be based on the input ID. So last time we already know, if you use the tensor, there will be three kinds of array. So last time we have the three array. This is the ID, and then we have the class, and then we have the word, and we have the set, and then we have the position of each of this word. And when we have the ID, so we use this ID to generate what will be the next or what will be the best answer to represent this question. So the parameter is almost the same with the text generation. In the text generation, we have also maximum length and the number of inter sequence is 1, because we just have one time. We just have one time like this one. You can try if you want to generate more than one, but if you use the GPT-2, I think when you have more than one, the result may not be good. So this is the context. So GPT-2 is a large transformer base and blah 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 is trained to predict the next one in the sequence. So after we have this context, we have the question, what is GPT-2? In order to generate the answer, we need to put the question, and then we need to put the context, and then we will output the tokenizer. So it means we will do the decoding, and the decoding will be based on the output IDs. So the output IDs will be inserted into the decoding, and then we will show what is the answer. So the answer will be like this one. Because this is just a very obvious example. So this is a very easy one. Of course, you need to put more context here, or you need to put more condition in order to make a better answer. So in this case, the answer is the same with the context. You can also do the summarization. What you did on the assignment 2, where you have the summarization. The summarization means we can make the summary of particular sentence. So summarize the following text Yeah, we have this one. OpenAI developed GPT-2, a large model capable for generating content and diverse text. It has many applications such as chatbot, summarization, and creative writing. However, it also risks concern with misuse, such as generating fake news or spam. So we can define the summarization. Again, we can define the token as long as you have the prompt. So you can make this as a token. And this token, you can just directly input with the tokenizer. So this is the summarization prompt. You do the encoding based on the Python, and then we want to generate. So the generation means I want to generate the summary of this text. We can also define how many words that you want to show from this summary form. So here you have the maximum length. Okay. The number of beams usually it is just to define how many of the in this case it is not clear about the beams. And yearly stopping is true. Yeah, if we have one another length, and if there are some repetition, usually they will stop. Yeah. So you can see if we decode, we want to get the summary output, and this is the summary output. OpenAI developed GPT-2, a language model capable for this one until 100. And then after it finishes, so you can see the summarization. Okay. Until some part, it will be repeated. For example, OpenAI is open source, 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 and so on. Okay. So this kind of things, of course, you need to consider about the maximum length that you want to decide. If the length is lengthy or if it is very long, of course, there might be some issues with the repetition. So in this code, I will also explain some extension of BERT. So when we use the BERT, you still remember what is BERT? It is the bidirectional encoding representation. So we use only the decoder. However, we can extend to BART and T5, where those two do not use only encoder, but they use encoder and decoder. So in this slide, I think you already know that if we use BERT, it means it is only encoder. If we use GPT, means this is a model with only decoder. And if we want to use the decoder, encoder and decoder models, means we need to apply another pre-trained models. So some of the pre-trained model on this is T5 and BART. So I didn't just explain in detail for those, but let's try to figure out how to use it in the transformer pipeline. So BART is a sequence transform for text generation and text understanding. So it is pre-trained using both the autoencoder task So for example, we can corrupt and reconstruct the encoding, and it is effective for summarization or translation or text completion. So if if you want to do the summarization, you can use BART as well. If you want to do the translation, you can use BART. And if you want to complete your text, you can also use BART. The other kind of pre-trained model, we call it T5. T5 is this one. Text to text transfer. So there are five T. So that's why they call it T5. So it will convert all analysis into a text to text format. For example, you want to translate English to French. So hello, it will give you the output bonjour. So this is very famous to use the T5. So it is highly versatile, covering tasks like summarization, translation, and classification. So the idea for the modeling, it is just replace the model that you want to use. If you use BERT, then you can just use the BERT. If you want to use GPT, you can replace the BERT model with GPT. If you want to use T5, then you can just replace this one with T5. And the Hugging Face provide the T5, which is the T5 small only. So if you want to have the bigger one, I think yeah, you need to pay some money. So in this case, we have text, and then yeah, this text is Hugging Face, this company that develops tools for natural processing, which is Bernardino and so on. And I want to summarize. So this summarization is based on the task here, summarization, and I'm going to use the model T5 small. So the T5 summarizer means I would like to use the text and then text summarized with the maximum 20, and we can also define the minimum length, for example 10. So here for the model, yeah, they have another model and they have another data they retrieve. So using the T5 summarization, Hugging Face is a company that develops tools and so on, and you can see now the summarization is more about the abstract. So you already know in the text summarization there are two. The first is extractive, and the other is abstractive. So using BERT or using GPT, when you want to extract or you want to summarize, most of them will be extract. So you select one. But using the T5, you can have the abstractive. So you can create a new sentence. So what BART? So BART is pre-trained model, and it has been developed by Facebook. So you can use only some of the pre-trained model given in the Hugging Face. This is BART. So the task is summarization, and then the model is Facebook BART. And again, you want to summarize using the BART, and then text. Then let's say I want to specify maximum length 17, the minimum length is 10, and I want to show the summarization. As you can see, yeah. Now the data is quite big. It's about 1.6 giga. So yeah, every model they have different size. but is one of the good prepaid model. However, the size is very huge because it contains of the encoder and decoder. For Word, it is only encoder. For GPT, it's only decoder. So the size will be still lower than one. But shows are very big, especially for the tasks that you need to do like summarization. So when you use the part, you can see the Hugging Face is a company that develops tools for natural language processing. So the text that they summarize is using the extractive. When you use the T5, the text summary is abstractive. And you can also use the T5 for the question and answers. So the pipeline, you can define this pipeline. You can try to figure out from the transformer library, and then you can define for this model. Let's say I want to use the text to text generation using the five, and then I have a question. What does Hugging Face develop? And this is the context. So I will give the input. So the question and the context will be the input, and then I will put the input into the pipeline that I already defined. In this case, the pipeline is text generation. I use define. So there's a question, what does Hugging Face develop? The result is tools for natural language processing. So they try to find the keyword that is relevant with question. This is on the context. So the answer is quite relevant. So T5 is very powerful, especially for the text-to-text generation, like this question and answers. For the text generation using BART, or we call it this is abstractive generation. So we also can use the text-to-text generation using the Facebook BART. So there are several models that you can apply to. Let's say the BART Labs, and previously is BART Labs CNN. So you can refer to the Hugging Face, what the best model and what is the free model that you can access. Or if you want to use some commercial one, you can check how to get the API. So this one is the model, and then this is the prompt. Once upon a time, it's a small village. So the BART text will be based on a prompt, and then let's say I want to generate 100 text, and then let's have only one sequence. Because we are using different model, now you can see that every time it will create another data, and it downloads this data into your environment. So if you look at this result, but once upon a time in a small village and empty. So you need to look at what is the purpose of each of the model. So it is difficult to understand each of the model. Sometimes people will try like trial and error, which one is the best, which one is not good for the text generation. Let me give some summary. So in the summary, For bird, you can try. If you want to do with bird for your project, you can try with bird is uncased. Is still bird is uncased. So those tools are considered as free written models that you can use in the database. For the GPT, there are GPT-2 and distill GPT-2. So the word distill means this is smaller. Maybe if this one is quite big in the model, this one may be less small than the original word. Maybe it is like 100 mega less or 100 mega less than the original one. For the transformer-based encoder decoder, so you can use the P5 small, you can use part-based. So part-based, we already learned previously. We can use the part-based, part-plus CNN. Okay. For the other kind of bird, there's a variant, Roberta. So the free one, you can use the Roberta fish and still Roberta fish. For the multilingual, it means if you want to do the translation, you can use the XLM, Roberta fish, and Bird. There's also some domain-specific models. It means it depends on the field. Bio, this is for the bio-related domain. So bio is something related to DNA or something related to the medicine, pharmacy. FinWeb, it is domain for financial. So they collect a lot of data for financial, and then they develop a written model. And this FinWeb can be used for specifically for financial. Yeah, you can define also what kind of bird that you want to use. So some of them are available in the database. So you can explore the domain specific model. And let's say you want to use some speech and vision-based model. Let's say you want to make navigation from people who speak something and from speech to text. After you convert from speech to text, you want to train with the pre-trained model. And you can use this one with Fact2 based on based batch 32. So this is for vision and this is for the speech. So in summary, yeah, maybe this is just for short. When you use the word, we learn about word, and then we know that it is kind of MLM, mass language model. So the word will be mass in some cases, and then we want to predict what will be the best word when it is already mass. Or the other kind of objective can be for the next sentence predictions. So if we have a sentence and we have separator, and we can look at what is this sentence, whether it is the next or not next. So we can have the probability. If this is continuity, then the probability of next is high. But if it is not related between the first sentence and the next sentence, then the not next will be high. When we do with the verb, we can do something related to the QA, question and answer, text classification, and name entity regulation. If you use GPT, GPT is the decoder only. Verb is encoder only. So we can also look at the objective. This is also language model. So in the causal language modeling means usually we can use some function to generate the text, so natural text generation. Natural text generation means we can generate text or we can do the summarization. So the GPT is good on this use case. For what? It is encoder and decoder. For what? It uses denoising autoencoder. It is robust to noisy inputs, and we can use summarization, translation, question and answer. For the T5 transformer, it is encoder and decoder, and this is for text-to-text generation. It is unified framework for all tasks, and the T5 is good for translation. The summarization is also good, and also the use case can be used for the question and answer. The other kind of variant like Roberta is for BERT. Okay. Pro means robust. BERT. We have learned about BERT, and they just use the addition of A to make it. This is based on the permutation-based language modeling. And just the bidirectional context therapy is used for handling any text generation. This is number. It is the smaller version of BERT is based on the encoder. This version means we have a lightweight. Lightweight means the model is very small. It's not that small. Maybe we can still want to make something, but it is smaller than the original BERT. And it is faster. Of course, there will be some trade-off. If you use the BERT, the original BERT will be better than digital BERT. But when you use digital BERT, you can use maybe in your smartphone, or we can use with some small device where the device has validated memory. So we can use this for classification. We can use it for the medical generation. And Electra, this is another kind of model. We can look at this is also based on the encoder. And this is the efficient pre-training. You can use it for the sentiment analysis. You can use it for the text classification. Okay, I think that's all. We can learn about the pre-trained model. Those pre-trained are available, and please try to use it for your project if it is possible for your research. Because I think it is good for your experience.